Now let's discuss factors. This is a fairly brief topic, at least for this learning cycle. We'll get much more into factors in a later learning cycle. But even though it is a brief topic, it is an important one because factors are used to represent categorical data. And categorical data is an important part of data analysis and statistics. Factors are stored as integers with labels. If you think about categorical data, you have different categories, what R calls levels, and those factors are predefined categories or predefined levels that distinguish one category from another category. So R simply uses integers to denote the different levels of the categories and attaches to those integers labels. Those integers are not indicating any particular numerical quantities, but they are indicating different levels of the factor. So let's take a look at using R with factors. It is quite typical when we record data to indicate factors with numerals. In this case, I have this factor called study group. Right now, R doesn't know that these are not numbers. If I were to create this vector study group based with the numbers 1, 2, and 3, it's going to think that study group is in fact numerical. If I look at the type of data that I have for study group, it's double. So it thinks that 1 means the quantity of 1, 2 is the quantity of 2, 3 is the quantity of 3. But indeed, these were just numerals or labels that we gave in our data set to each of these different levels of a categorical variable. So that's where the factor function comes in. The factor function will take that variable and tell R these should not be considered numbers, they should be levels of the variable. So I'm going to go ahead and apply that. When I look at the type of the study group, as we already saw, it is double. But I put the factor in group factor, and if I look at that type, notice that it's given as an integer. Now, even though it's recording it as an integer, it's still a specially stored value that doesn't treat those as numbers, but rather treats that just as integer storage of levels of the factor. If I look at the class of study group, that is the vector before I changed it into a factor, it's numerical. But if I look at the class of group factor, notice it's not numerical. Even though the type of data is an integer, the group factor classification is factor. Remember in the past when we had integers and we looked at the class of that, we also got integers. Here we're getting factor. So that integer storage is simply a special storage for a categorical variable. If I looked at the attributes of my vector, there were none, but if I look at the attributes of group factor, notice that I have 2 of them. The levels of the factor, which are designated 1, 2, and 3, and then the classification of the factor, which is, naturally enough, factor. If I don't want to leave these levels as the numerals 1, 2, and 3, and typically I don't, I can rename these, and I can do it with the labels command. So here I'm going to reintroduce study group. Remember that study group were just those numbers. I'm going to do this again. I'm still going to use the factor function, but I'm going to add an argument. And this argument tells R, let's go ahead and change this from 1, 2, 3 to placebo, treatment A, and treatment B. So I'm going to go ahead and run that. Let's go ahead and look at group factor to see what it looks like. Notice that. Placebo, treatment A, treatment B. And let's look at the attributes. The attributes are placebo, treatment A, treatment B. The class is factor. If I look at the type of group factor, you're still going to see integer. That means behind the scenes, the data are still stored as integers. That makes it more efficient for R than actually storing these characters of placebo, treatment A, treatment B. So really, in the storage that R is doing for this factor, it has the integers 1, 2, and 3, but anytime you now want to look at those factors, it's going to convert the 1 to placebo, the 2 to treatment A, and the 3 to treatment B.